On the other hand, it's possible that no received code word will be jointly typical with x of 1, and that event is contained in T1 complement. So, yes?
Excuse me. T1 complement is not T1, but not any of these.
Yeah, so it's sort of like,
T1 and all possible
well,
cases complement.
I mean, here's T1, let's say. And these could be T2, T3, T4, T5, and so on. So, in this kind of a Venn diagram, a region in here would be a case where both T1 and T something else occur. That's a decoding failure. We could have something just in T2. That would be a case where the decoder returns 2. But we're assuming that what we sent was 1. So therefore that's an error.
Undetectable.
Exactly, that's an undetectable error. On the other hand, we could have something here, which is not in any of the typical sets. That's not jointly typical with anything, and so therefore that's a decoding error. So the only case, the cases where errors occur are out here. In other words, T1 complement, and anywhere where some other event could also occur along with T1. So that's basically T1 complement union T2, union T3, union T4, and so on. So in other words, T1 complement, union T2, union T3, union, and so on, up to T2 to the n. So this error probability of error given W equals 1 is equal to the probability of T1 complement union T2, union T3, union T4, and so on up to T to the NR. Now, when we take unions of events in probability, I know that the following is true. This is the union bound. That's less than or equal to the probability T1 complement plus the sum from I equals 2 to 2 to the NR of the probability of TI. So now I have an upper bound on that probability. Last time we showed one of the properties of joint typicality was that the probability of not being in the typical set, so in other words, if x and y occur together, the probability of not being in the typical set goes to 0. So we said from last time, probability of, remember, y from 1 to n is the channel output. We're assuming that code word 1 was sent. So therefore, y from the vector y1 to n is the channel output given that code word 1 was sent. So the probability that these two, this channel input and that channel output, are not jointly typical. Excuse me, let me back up. The probability that these are in the typical set, we showed that this goes to 1 as n goes to infinity. That's one of the properties, or one of the features of joint typicality, is that the probability of the typical set goes to 1. So, that means the probability of T1 complement, which is the probability that these two, this output and input, are not in the typical set, must go to 0. In other words, we can eliminate this and only focus on these events. Okay. So, what is the probability of Ti? This is the probability that y1 to n and xi are in the typical set for I not equal to 1. If I is not equal to 1, then remember, this is a random code book, so therefore x is chosen independently at random in the same manner as x of 1. So remember from last time, that's kind of like x tilde. Y is dependent on x1, and therefore it's independent of any other possible code word that I can send because they're random. So therefore this is like y tilde, where y tilde and x tilde are both drawn at random according to the marginal distributions of x and y, but they're independent. Now last time we had a result that said if x and y are drawn independently, but with the same marginal distributions as the original x and y, there's a certain probability associated with that. And what is that?
The information plus 3 epsilon.
It's bounded, yeah, so basically it's bounded by the mutual information. So, this probability is less than or equal to the sum from W equals 2 to 2 to the NR of, excuse me, I'm not doing the sum just yet. I'm asking what's the probability of Ti. The probability of Ti is less than or equal to 2 to the minus n mutual information minus 3 epsilon. So therefore, the probability of error given that code word 1 was sent is less than or equal to the sum from W equals 2 to 2 to the NR of probability of Ti, which is itself less than or equal to the sum from W equals 2 to 2 to the NR of 2 to the minus n I xy minus 3 epsilon. Now, this term is not dependent on W. So therefore this is equal to, how many terms are there in this sum?
2 to the NR minus 1.
2 to the NR minus 1. Times 2 to the minus n y minus 3 epsilon.
Actually, I meant 2 to the NR minus 1 below, not in the power.
Oh yeah, 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 yeah.